We're back, and this week, a recent unprecedented digital mapping project led by the University of Birmingham in conjunction with the Ludwig Boltzmann Institute for Archaeological Prospection and Virtual Archaeology has discovered a host of previously unknown archaeological monuments around Stonehenge. Yes, I know, I'm excited. Nerd! Remote sensing techniques and geophysical surveys have discovered hundreds of new features. The startling results of the survey, unveiled in full at the British Science Festival, include 17 previously unknown ritual monuments dating to the period when Stonehenge achieved its iconic shape. Dozens of burial mounds have been mapped in minute detail, including a long barrow, a burial mound dating to before Stonehenge, which revealed a massive timber building, probably used for the ritual inhumation of the dead following a complicated sequence of exposure and excarnation or defleshing. Check out the link below for more information. According to MIT, understanding how objects are spinning, where their centers of mass are, and how their mass is distributed is crucial to any number of actual or potential space missions. Space. From cleaning up debris in the geosynchronous orbit favored by communication satellites to landing a demolition crew on a comet. Super cool. The university has developed an algorithm tested aboard the International Space Station that analyzes the rotation of objects in space. The algorithm was very accurate on all but one measure, using 2 small satellites deployed to the space station through MIT's SPHERES project, which envisions that herds of coordinated satellites the size of volleyballs would assist human crews on future space missions. For more information, click on the link below. At the University of Texas in Arlington, researchers have discovered a way to cool electrons to negative 228 degrees Celsius without external means and at room temperature, which could lead to electronic devices that function with very little energy. The process involves passing electrons through a quantum well to cool them and keep them from heating. The team used a nanoscale structure, which consists of a sequential array of a source electrode, a quantum well, a tunneling barrier, a quantum dot, another tunneling barrier, and a drain electrode to suppress electron excitation and to make electrons cold. So, as most of you have already heard, Apple has announced several new devices to the market, including the iPhone 6 and the iPhone 6 Plus, and its own version of the smartwatch. Of course, it can tell time, however, it's loaded with a ton of features that have the possibility of changing how you live your life. Users will be able to unlock doors to hotel rooms at the facilities that incorporate the technology into their business. They can also check in on airlines, get directions, tweet, call, communicate, pay for stuff, track your health, and much more. Moving on to the phones, Apple finally got on the bandwagon of bigger is better with its new iPhone 6 Plus that features a 5.5-inch screen. Like, hold up, Apple. That is extreme. The new phones also have a new A8 chip, which Apple says is 13% smaller and has up to 25% better performance. Me, being the dedicated Android user that I am, I'm curious to see how these devices actually work. So if you pre-ordered the phones or watch, send in your comments to me at megan.zimba@advantagemedia.com and tell me what your favorite features are, what your least favorite features are. Is the fingerprint sensor really worth it? Do we really need a watch to do more than just tell time? If you get bored and want to actually send the device to me, Apple, hint hint, I wouldn't mind, testing them myself. Well, that's all for this week. If you're craving more wireless fun, check out wirelessdesignmag.com. Check us out on Facebook. Go to our Twitter page. Visit our YouTube channel. You know the deal by now. I'm Megan Zimba, and I'll see you next time in the Hotspot.